All right, good afternoon, everyone. Seems like we have a bit of a smaller crowd. I'm wondering if we might be able to come into these two center sections of chairs. Please. Just to make it just a little more intimate. Thank you, everyone. All right, it's 3:31, so I'm going to go ahead and get started. And I'd like to start off today with a question. What if? What if you could build software once and have it run anywhere? Whether it's a bare metal server, a virtual machine, or even a container. What if you could move a legacy application into the cloud without having to rewrite it? What if you could empower your applications to recover from failure on their own without needing a central command server and without needing human intervention? Well, I have news for you today. You can do all these things today with Chef Habitat, a new open source project from Chef. Now, Habitat goes beyond infrastructure automation, beyond cloud automation, and into the world of application automation. We'll go deeper into what I mean by application automation in just a moment, but first, let's cover who I am. I'm Nell Shamrell Harrington. I'm a senior engineer at Chef Software. I'm from Seattle, Washington. This is my first time in Australia, and I'm enjoying it very much, especially because it was snowing in Seattle last week. This has been a very welcome break. You can tweet at me at @NellShamrell or email me at nshamrell@chef.io, and I will re-show these contact details at the end of this presentation. So let's talk about why I'm here. Why did I fly a total of 20 hours, I think? Well, the reason I was asked to speak here, in this track in particular, is because Habitat is 100% open source. It's distributed under an Apache license, and you can check out all the source code at github.com/habitat-sh. Now, before we go into Habitat in particular, and we are going to go deep, we're going to see a lot of code and a lot of demos, I'd like to invite Ken Thompson of Microsoft to say a few words about Microsoft's commitment to open source.
Thanks, Nell. Hey, everyone. So I just want to have a quick chat around Microsoft's open source strategy. So you might have noticed a fair change in Microsoft's approach to open source, especially over the past 3 to 5 years. And ultimately, that's all about giving you guys choice and flexibility to run the applications and workloads that you want to run that work best for you and your teams. So this goes across management tools like Chef and Chef Habitat, but it's also about application stacks, languages and frameworks like Node.js and Java, and databases, and of course, Linux virtual machines. So we have a look at how we're approaching that open source strategy. There's 4 main areas where we're focused on. The first is enabling open source workloads. So this is very basics enabling Linux virtual machines, whether it's on Hyper-V on-premise, Azure Stack, and obviously Microsoft Azure in the public cloud. But it's also about enabling support for open source languages and frameworks on our PaaS-based services. So we have support for Node.js, PHP, etc. on Azure App Service. So you can just bring your code, whether you're running web apps or you're looking at Azure Functions for serverless technology. But then we're also, above just enabling open source to work really great on Azure, we're providing integrated solutions. So these are things like Azure Container Service, where we provide the choice of Docker orchestration engine of the top 3 open source projects out there. It's also things like HD Insight, where you get a Hadoop cluster, basically as a platform as a service offering. So full open source Hadoop stack, but we manage it for you, make it really easy to spin up and get value fast for your business. That's what those solutions are really focused on. We're also releasing key Microsoft products into the open source domain. So notable ones being PowerShell, so you can now run that whether you're running Mac, Linux, or Windows desktop to manage Linux or Windows workloads. And we're participating in a bunch of open source projects. So Linux kernel, doing stuff there around Hyper-V and Azure support, but also projects like Docker, where we're working quite closely with those guys, and we're also working quite closely with partners like Chef. So back to you, Nell.
Thanks so much, Ken. All right, so that's Microsoft's general approach to open source. Let's go deep into this open source project in particular, Habitat. Now, before we go into the what of Habitat, we first understand the why. And the reason Habitat was created is pretty simple. Building and running software is painful. You have to have different runtimes for different languages of applications. You need one runtime for a Ruby application, one runtime for a Java application. You need different packages for different operating systems. For a Debian Linux system, you need a different type of package than you would a Red Hat Linux system. And I don't even want to start to go into the difference between packages for Linux and Windows. You need different packages for bare metal servers and virtual machines and containers. So this is a lot of where our pain lies. Habitat seeks to alleviate this pain by building and running transforming applications, including legacy applications, into modern applications. And what I mean by a modern application is an application that is immutable, that is agnostic to running environments. It should be able, a Java application or a Ruby application should be able to run on the same runtime environment. It reduces complexity, especially when you're moving an application into the cloud rather than adding complexity. And it enables scaling. I think we all know that having one server in your closet running your application is no longer enough. In order to be successful in this business environment, in this technological environment, you need the ability to scale out quickly, and your application needs to enable you to do so. So how you build a modern application starts with the source code repo. This is where you keep all code associated with the application, including the application code itself and the code for automating that application, the code it takes to deploy it and run it. Now, what you'll next do is compile all of that code into one artifact. This is a software package. And that package will then be sent to a central artifact depot. This is where you can browse artifacts, you can store your own artifacts, and you can download artifacts made by others. And finally, you're able to pull that artifact from that repo onto wherever you want to deploy it, whether it's bare metal, a container, a cloud instance, or a virtual machine. This artifact should be able to run anywhere. So Habitat was designed with this workflow at the forefront. And if you're familiar with the 12-factor app, this is very similar. In fact, it's based on it. So now that we know the what, or the why, excuse me, now let's cover the what of Habitat. Briefly, Habitat is a new technology to build, deploy, and manage applications in any environment, from traditional data centers to containerized microservices, from the legacy infrastructure of 30 years ago to the bleeding edge infrastructure innovations of today. The reason for this is that in Habitat, the application itself is the unit of automation. The application package, that artifact we create, contains everything needed to deploy, run, and maintain the application. So that's a lot of promise and potentially a lot of hype. Let's go over exactly how this works. So when you package an application with Habitat, you start here with the user. This is you at your workstation. And it doesn't matter whether you have a Linux workstation, a Mac workstation, or a Windows workstation. You can build a Habitat package on any of those. Next, you will create a plan. This contains instructions on how the application should be set up wherever it is deployed. Now, if you're creating a package for Linux, you would write this plan in Bash. If you're creating it for Windows, and we will see a demo of this later in this presentation, you would write it in PowerShell. Next, we take the application, the compiled application, and that plan, and put them into one artifact. Now, this artifact is cryptographically signed with a key, and I'll show you how we use that key in just a moment. Then you can optionally upload that artifact to the public Habitat Depot. This is our public artifact repository where you can find Habitat packages from developers all over the world. So this is what that public depot looks like. And in it, you can access it at app.habitat.sh, and I've been searching for a node package. And we're going to use that core node package down at the very bottom in a demo in just a little bit. So that's how you package an application with Habitat. Now let's cover the other half, how you would run an application with Habitat. So if you have it on the depot, you would start off by pulling that artifact on the depot onto wherever you want to run it. Again, whether it's bare metal, containers, you could have it be a machine image or on a VM. Now, if you're not using the depot, you can also upload it wherever you want through SCP, FTP, whatever protocol you use to get that package onto where it needs to be deployed. So you then run that package as what we call a service under a supervisor. And we'll go into what we mean by a service and a supervisor in just a little bit. But let's look at an example. Once you have that application running somewhere, in this example, it's a VM. With the supervisor, VM running under a supervisor, you can still get information into that application and out of that application through a standard RESTful API. This is really useful when you have something like a load balancer that needs to send traffic to that application running on that VM and run health checks on that application to know whether the underlying infrastructure is healthy. So the real magic of the supervisor comes when you have more than one instance of an application running. So let's say we have 4 VMs here all running the same Habitat package. The supervisors on each of these VMs form a ring. They use that key that we use to sign the artifact to authenticate into the ring. They have to all be signed with that same key in order to be able to communicate. And all of this communication is encrypted over a gossip protocol. So they can use this to self-organize into different topologies. And we'll see an example of a leader-follower topology in just a little bit. So Habitat has many parts. When I last spoke to Jamie Windsor, one of the creators of Habitat, he described it as an umbrella over many components, all designed to help make building and running your application make it so you can do that once and run the application anywhere. Now, a lot of these components are still under development, and even though they're certainly very promising, and I'd love to tell you about them, I'm here to talk about what you can do with Habitat today, how you can create and run application packages that run nearly anywhere, how you can move existing legacy applications into the cloud without having to rewrite them, and how you can give your applications the intelligence to self-organize and recover from failure on their own without the need for a central supervisor or controller. I want us to understand what we can do with Habitat today, and then together, since this is an open source project, we can start shaping where it's going to go in the future. Where Habitat goes from here is going to be largely influenced by our community of users and our community of contributors. So we're going to discuss 3 main things today, and the first is the Habitat Supervisor. This is what's used to run your package, and I think this is where the genius of Habitat shines. The second is the Habitat packaging format. This is what you use to create those artifacts for your applications that contain the compiled application and everything needed to run it. And then, although you can certainly use Habitat without containers, and we will look at a demo of this, Habitat shines when it comes to working with containers. It doesn't replace Docker or Mesosphere. It complements them and makes them work even better. So let's start with that Habitat Supervisor. Now, briefly, the Habitat Supervisor is an intelligent runtime with deployment coordination and service discovery. Now, that's a big mouthful of words to throw at you, so let's break this down. The Habitat is what allows you to run your application natively on hardware, in a VM or cloud instance, in a container, Docker containers included, and you can use it with container management services like Mesosphere or Kubernetes or Docker Swarm. And one of the main functions of the supervisor is to be a process manager. What this means is it starts up and monitors the package. When you pull that package from the depot or upload it, it will automatically unpack that package and start running it. It will also monitor it. Additionally, the supervisor is what receives and implements configuration changes. So if you upload a new version of your package, say you have a security patch that needs to go in there, the supervisor will be responsible for making any configuration changes associated with that new package. And it also runs services. So let's take a look at what I mean by a service. A service is one Habitat package running under one supervisor. And the simplest example is one supervisor running one service. So in this illustration, we would have one VM running one supervisor and one service. But let's not just look at an illustration of it. Let's look at an actual demo. I'm going to switch to the demo computer. And here I am on an Azure Linux VM. And I have uploaded my package to this VM. Just going to show it. It's going to do an ls, and there it is. And Habitat packages end in this .heart format. Now we're going to go over how we make those heart packages in just a little bit and why they're called heart packages. But for now, let's go ahead and start this package. All we've done is uploaded it onto our VM. So we start it using the command sudo hab start and the package name. Now this will install, initialize, and run everything associated with the application. So I went ahead and started it, and it's running on port 8080 on my VM. So if I go out of my terminal and open my web browser and go to the IP address for that VM, again, we're going to port 8080, I will see my application running. So this is how simple it is. This is how fast it is. All I had done prior to the beginning of this demo was upload that package onto the VM, and I have a running application with minimal manual configuration. So I'm going to switch back to my slides. So when we go beyond one service, when we go beyond that simplest example, we need what's called the supervisor ring. And let's look at an example of this. Let's say we start off with one supervisor on a VM running a MySQL package. Now, as our application grows, we decide that we want a MySQL cluster. So we spin up 2 more VMs and install that MySQL package on them. Now, because they were signed with the same key, they're able to communicate with each other. They communicate over that gossip protocol, and remember, all of this communication is encrypted. Now, with a MySQL cluster like this, it's common to run a leader-follower topology, which means once we have those 3 VMs running MySQL, we need to elect a leader. Now, Habitat has a built-in algorithm for electing a leader in a cluster such as this. So it runs an election automatically, and let's say it selects this one here at the top as the leader. That means this one, again with no human intervention, is going to start receiving all the write requests to this MySQL cluster. And these 2, the followers, are automatically going to start receiving all the read requests. Now let's take this further. Let's say something bad happens. Something goes wrong, and this VM with the leader supervisor goes offline. Well, the other 2 VMs running that same supervisor are going to notice this when they cannot connect to the leader over that gossip protocol. And they're going to automatically take it out of that supervisor ring. If it's not responding, it's out. So now we have 2 followers, and we've promised a leader-follower topology. This means they need to run another election to decide on a leader, and they will do this automatically. They'll run that election algorithm again, and let's say this one receives the election, wins the election. It'll start receiving all the write requests, and this one over here, the follower, will start receiving all the read requests. All of this happens without human intervention and without a central control server. What this illustrates is that Habitat assumes that failures will happen and they are normal. We don't try to anticipate every edge case beforehand because, frankly, we can't. There will always be something unforeseen that happens somewhere in an application's life cycle. Now, I think we all know of examples of flood during Hurricane Sandy that took out some data centers in New York, and in other cases, fire. So those are the most extreme things that we cannot predict. So Habitat assumes that some failure will happen somewhere and that the healthy components will self-organize and reconverge. They have the intelligence to do this on their own without any central coordinator. Now, the supervisor ring can be in a couple of different topologies. We just saw that first one, the leader-follower topology with that MySQL cluster. But they can also run in standalone. This assumes that every member of the supervisor ring is working as an individual entity, but one that is still in communication with all the others. If one of them goes offline, the healthy components are going to notice it and take it out of that supervisor ring. Now, the supervisor is also in charge of handling updates to that package or configuration changes and rolling them out to the rest of the ring. So if you have a package up on the public depot, the supervisor will realize when a new package is available, a new version of that package, and deploy it according to a defined update strategy. And there are a few different update strategies that you can use with Habitat. The only one currently supported is all at once. This is when a new package becomes available, all the supervisors of that ring will update to that new package all at the same time. Now, the other one, which is coming soon, is called rollouts. So this means, say we have a supervisor ring with 4 supervisors. One of them is going to update. Only when that one's finished updating will the next one update, and only when that one's finished will the next one update. There's only going to be one updating at any given time. So that's the supervisor, which is used to supervise and manage applications packaged with Habitat. Now let's step back a bit in the life cycle of that package and talk about how we make that package for the supervisor to supervise. And we do that through the Habitat packaging format. This is what you use to create your artifact on your workstation. So Habitat packages come in a heart format because we heart you. I didn't realize this conference would be over Valentine's Day until I got here, which struck me as very appropriate. But what HART stands for is Habitat Artifact. And these packages contain the compiled application itself. For example, if you have a Ruby on Rails application, it will contain that application. If you have a Java application, it will contain the compiled version of that application. And it also contains everything needed to deploy and run the application. So enough with the talking, let's look at another demo. And let's look at creating a Linux package on a Windows workstation. So let me pull that up. And switch over computers. So here I am on my Windows workstation. And the application we're going to package up today is a Node.js application that's in GitHub. So there's 3 main files that make up this application. The first is server.js. And what this package does is it gets the port value. This is the port the package is supposed to, or the application is supposed to run on, and a message value of something to display. So it pulls these variables, and we assign values to these variables here in the config.json. So that file is in that config directory right here. We go into config.json, and this is where we provide the values for those variables. So our message we want to display with this application is hello world, and we want it running on port 8080. So the last file that makes up this application, I'm going to grab a sip of water. Go back, and the last file is package.json. And among a few other things, this defines any dependencies on other node modules. So we have one dependency on this case. It's depending on the nconf node package module. So this means in order to run this application, we need to install that dependency as well. So that is the application itself. And when I'm ready to clone this application to my workstation, I'm going to open up PowerShell. And I'm going to run git clone and pass it the URL for that repo. So it's going to clone it into a directory on my workstation, the My Tutorial app directory. And if we look inside that directory, or if we cd into that directory and look inside of it, let's do an ls, we'll see we have that source directory. That's where those 3 files are that we just saw. That's where all the source code of our application goes. Now, in order to automate this with Habitat, we're going to look at what's in that source code real quick. In order to automate it with Habitat, we are going to need to make a new directory at the same level of the source directory and call it the Habitat directory. So once I make that directory, there it is. I am now going to create a new file called plan.sh in that directory, and I'm going to write that file using Visual Code. So when I type in code habitat/plan.sh, it's going to open Visual Code for me. There it is. And I'm going to add in some content to this plan.sh file. So there's a few things that I'm going to define first. This is essentially the metadata for my application. So the first attribute of that metadata is origin. The origin is essentially the namespace for your application, and it's the name of the key that we use to sign the application. So in this case, I'm going to call my origin Nell Shamrell. There it goes. Then the other thing I want to highlight is this dependency, package deps. These are other Habitat packages that our application is dependent on. So remember, we were looking at the public depot and we saw that node package under the core origin, the core namespace. We're going to use this for that application. And finally, we're also going to define what port we want our app to run on, which in this case is 8080. Now, by default, what Habitat will do when you tell it to package an application is it will try to download a tarball of it, verify that tarball, and unpack it. But in this case, we're going to override that behavior because we don't need to download a tarball of our source code. We already have it in there in the same repo. So we're going to add in what are called callbacks. Callbacks define the behavior Habitat should use at certain points in the application's lifecycle. So in this case, I'm going to override them, so I'm going to tell them to return 0 here in Bash. Now next up, I'm going to define how I want this application to be packaged by the do build callback. This defines how this application will be built. And among the things I'm going to do in this callback, I'm going to copy the application code from the source code into a different directory I'm going to build the package from. And I'm also going to run npm install. That will install that node module that we're dependent on. So after I build the package, I'm also going to define how the package will be installed. And I do that through the do install callback. So as you can see, I'm copying a couple of files into certain places and making directories for my node modules and then copying information there. So this will define how my package should be installed. And after this callback, I'm going to save my file, head on back to PowerShell, and now I'm going to actually build this package. And I do that by entering what we call the Habitat Studio. This is a clean environment so you can build your package and run it without having to affect your host workstation. So in Windows, this is a Docker container running on your workstation. So I entered the studio by running hab studio enter. And when I go into there, that didn't sound good. You're going to see this command prompt, which indicates that you're inside the studio. And how we're going to build that heart package is running this build command. So when I run this command, it's going to do a whole bunch of stuff, and I've sped this up a little bit for the sake of time. And I'm going to be able to tell that this build was successful because I'll see a message that says, I love it when a plan.sh comes together. So this indicates it was able to build my package successfully. So now I'm going to exit out of the studio, and I'm going to be able to see my new package in the results directory. When I do an ls on that directory, I'm going to see my new heart artifact. This was not here before we did that build. So it's the My Tutorial app, and it's built for Linux at this point, and it's a .heart file. Let me take that back just a little bit. There it is. Now this application right now will build, but it won't yet quite run. If you'd like to see the rest of the process of getting this running, check out habitat.sh/tutorials, and you can get your hands dirty and do this yourself. So now I'm going to switch back to slides. Now, as you've seen, Habitat plans use Bash for packages that will run on Linux. But, and this is preliminary, it's not quite production ready yet, but it is demonstrable, Habitat can also create plans in PowerShell for Windows. And let's not talk about it, let's just go straight into a demo of this. All right, here I am on my Windows workstation. And I am going to create a new file, a new plan, but this time the extension is going to be .ps1 because this is a PowerShell plan rather than a Bash plan. And in it, I'm going to put in some content, and this content is largely the same as what was in my Bash plan, but it's translated into PowerShell syntax. So after I save that plan, I'm going to go ahead and build this application. Now, because this functionality is still in development, I currently need to build it from outside the studio, but you will be able to build it from within the studio for Windows packages very soon. So I'm going to go ahead and run that build. And it's going to do the build, and I sped it up a little bit, but I'll be able to tell when it's ready because it will say, I love it when a plan.ps1 comes together. So it's aware of what language that plan is in. And after this, if I do an ls of the results directory, let's take a look at what's in there, or the habitat/results directory, I'm going to see my new Windows package. So this time it's going to end in windows.heart. So this means this is built for Windows with PowerShell. Switching back to my slides. Now, along with running Heart packages with Habitat, you can also export them to other formats. And by far, the most popular format people export Habitat packages to is Docker container images. And that brings us to the final topic we're going to talk about today, which is Habitat and containers. Now, getting artifacts to run anywhere is very difficult. We all know that. That's nothing new. Now, containers were supposed to solve this problem, but there's a lot of pain with their usage right now. One of the biggest pain points is that there's a major learning cliff between dev and prod. Who here uses containers in dev? Got a few hands. All right, who uses them in production? How long did it take you to get from using them in dev to using them in production?